Today we are going to be starting with Unit 2, Section 3, actually Section 4, my apologies. Unit 2, Lesson 4 is going to be dealing with a new term called similarity. But before we go to that, I thought we would need to go back and review a moment of what we have already learned. We know about dilations. We learned about dilations in Unit 2, Lesson number 2. And we learned that dilations are creating figures that are the same shape but not necessarily the same size. We know that when you have a dilation, it is either an enlargement or a reduction of a shape, and that the new shape will be oriented exactly the same as the old shape. When we talk about that enlargement or reduction, that enlargement or reduction always takes place in relation to a center of dilation. Now, to figure out whether or not you have a enlargement or you have a reduction, we're going to be taking a look at scale factor. When the scale factor is greater than 1, we have an enlargement, meaning that the figure has gotten bigger. When we have a scale factor that is between 0 and 1, that is called a reduction. Our figure will get smaller. Now, if we have the pre-image and the image, and we're looking for our center of dilation, all we have to do is connect corresponding points with a line. We did this where we actually drew a line that connected the pre-image and the image vertices. We made it a long line, and we did the same thing with another pre-image and image vertices, and where those two lines intersected, we knew that we had the center of dilation. So this was some of the things that we learned when we talked about dilations in Unit 2, Lesson 2. Today, we're going into similar figures. Similar figures, you may think, are the same as dilations. When we talk about similar figures are the same shape, but not necessarily the same size, very much like dilations are. However, they do not have to have the same orientation. Let's take a look at what we mean by that. If I take a look at these two shapes are examples of similar figures. If I look at the point B, the point B is at the intersection of the two smallest sides of this triangle. If I came to my other shape, the shape over here on the right, if I find where the two smallest sides intersect, the two smallest sides intersect at the point P. Do you notice how the point B in the first figure is on the left of the figure, but the point P is actually down in the figure? That tells me that these two are not dilations of each other. Instead, they're just similar figures. Now, when we have similar figures will always have corresponding angles congruent and corresponding sides proportional. Let's talk about what that means. If you look in your figure, you're going to notice that there are some markings within the angles. Angle A has one arc mark. If we look on the figure on the right, angle N has one arc mark. That means that angle A is congruent to angle N. If we look on the left figure, angle C has two arc marks. Angle M has two arc marks. that means that those two angles are also congruent to each other. In the figure on the left, angle B has 3 arc marks. Angle P has 3 arc marks. That means that those angles are congruent. So I know that my angles have corresponding matches. Angle A was congruent to angle N. Angle B was congruent to angle P. And angle C was congruent to angle M. That's what I mean when I say we have corresponding angles that are congruent. Well, what do we mean when we say corresponding sides are proportional? Well, let's take a look at the sides. If I take a look at the sides, in the first figure, I have 3 different sides. Those 3 different sides I'm going to call small, medium, and large. Now I am basing that solely on their lengths. When I take a look at the second figure, I see that it also has 3 sides. So I'm going to label it small. The small side is the 4. The medium side would be the 8. Oh, come on. Hold on, I'm having trouble getting my pen to work. I'm going to pause the video for a minute while I figure out what's happening with my... Okay, I'm back. I got my pen working again. So in my figure at the right, my small side is the 4. The 8 is the medium side. I know that simply because of the numbers. The numbers actually show me where my small, my medium, and my large is. I'm going to write that in the right color, in red. So that's medium. The 10 is the largest side in that figure. Okay, by labeling my sides small, medium, and large, it's going to make it easier for me to figure out the matchups. So let's look at the figure on the left. What is the small side on the figure on the left? Well, the small side is right here, the 2. What is the matching small side in the figure on the right? Well, that would be right here, the 4. So if I match up my small over small and turn it into a ratio, I'm putting 2 over 4. I'll do the same thing with the medium. My medium side is a 4. The medium side over here is an 8 on the right side. So that means that my medium matchup would be 4 over 8. The large side on the left is a 5. The large side on the right is a 10. So that means my matchup there would be a 5 over 10. Now, if these turn out to be equal, then I know that they are proportional. To figure out if they're equal, I'm actually going to divide them out. So I would actually take 2 divided by 4. That'll get me 0.5. 4 divided by 8 is also 0.5. 5 divided by 10 is 0.5. That shows that the sides are proportional. So the corresponding sides, meaning the small to the small, the medium to the medium, and the large to the large, are proportional, meaning when I make the ratios, they are the same. Well, now that I know that all my corresponding angles are congruent and my corresponding sides are proportional, I can actually say that these figures are similar. Now the notation that we use for that looks like this. Now when we write the notation for similarity, it's very important that you pay attention to the corresponding parts. What do I mean by that? Well, in the figure on the left, I started writing the name of that figure with the letter A, the vertex A. Well, if you pay attention to what we said with our angles, we said right over here, angle A was a match to N. So I had to start my next side with an N. We then went to B. Since I started the second side, or the second vertex I named on the left side was a B, then I come over and take a look and see what my angle matchup was. B matched with P, so P had to be the second listing in my figure on the right. My last one that I named in the figure on the left was the C. Since angle C was congruent to M, I know that M has to be in that matching position. That's what I mean when I say you have to make certain that you list your similarity in matching order. Notice the symbol that is between them. You see that little squiggle right there? That little squiggle is the symbol for similar. So anytime you see that squiggle, you know that we're talking about similarity. Let's take a look at an example that's not triangles. The definition of similarity works for any kind of shape. It doesn't have to be triangles. So if I look at these two figures, I am told that the figure on the left, EFHG, is similar to the figure on the right, TWKQ. I want to know what the angle or what the relationship is for the angles and what the relationship is for the sides. Well, I'm going to start off by identifying what matches up. So if you take a look at the order, E was listed first. It is listed on the second figure with a T first. That means that I know those are my angles that match. So I can say angle E is congruent to angle T. I can do the same thing with the next set of angles. I'm going to look at what is listed second. Second is an F over the next one. The second one, it is a W. So that means I can say angle F is congruent to angle W. If I take a look at the next one listed is an H. In the right one, it's the K. So that is my matchup. So that's going to be angle H is congruent to angle K. And the last of my matchups, I have a G and a Q. So that means I can say angle G is congruent to angle Q. Okay, so in my figure, E is congruent to T. F is congruent to W. H is congruent to K. And G is congruent to Q. And I can now easily see my angle matchups. Let's talk about the sides. Now that I have my angles listed, the sides should be somewhat easy. I'm going to be looking at my markings in my figure and find the matching pieces. So, if I look at the markings in my figure, if I look on the left, I have E to H joining my single arc mark to my double arc mark. That matches T to W in my other figure. So I know those are in a proportional relationship with the other sides. If I look on the left, F, H connects the 2 mark to the 3 mark. That matches W, K. So F, H matches W, K. If I look on the left, G, H joins my 3 to my 4. That's going to be KQ on the right. So G, H matches KQ. Oh, come on, Ben, there you go. And if I take a look on the left, EG matches TQ. So I know I can say EG matches TQ. Now, this is the only warning that I'm going to give you when you're doing these. Notice all of the listings of sides that I have on top came from the same figure. Let me write that a little clearer. The top was from the figure on the left. The bottom all came from the same figure, the figure on the right. It's really important that you keep the same figure on top. If I started off with the figure on the left on top, then I have to make sure every single one of my top numbers came from the figure on the left. Okay, very good. Well, now that we know what similar figures are, it's time to learn a shortcut. This shortcut works only when we have triangles. When you have triangles, instead of having to know all 3 angle relationships and all 3 side proportional relationships, there's actually a set of shortcuts. The first of the shortcuts that we're learning is called angle-angle similarity. It says knowing 2 sets, just 2 sets of corresponding angles being congruent is enough to guarantee that you will have similar triangles. So all you have to have is 2 sets of corresponding angles that are congruent. And that's all it requires in order to know for a fact that you have similar triangles. Let's take a look at what we mean. Remember, when polygons are similar, you have to name them in matching order. So when I ask you to look at this and look at whether or not it's similar and to write a similarity statement, make sure you're doing it in matching order. So here I have 2 triangles. I have not given you the lengths of any of the sides. The only thing that I have given you are angle measures. We have an angle measure of 30 degrees on the left at angle A. There is a matching angle on the right at angle X. It is also 30 degrees. On the left, we have an angle measure of 100 degrees at angle C. There's a matching angle degree on the right at angle M. That means we have 2 sets of corresponding angles that are congruent. We can say angle A is congruent to angle X. We can say angle C is congruent to angle M. Two angle congruencies. That means I have satisfied my requirements. Oops, sorry about that. I have satisfied my requirements for the triangles to be similar. Notice when I wrote my similarity statement, I matched angles. A, X. Well, let's do that in the right order, in the right color. A was 30 degrees. It matched X. I listed both of those first. Now, I chose to list my left triangle in alphabetic order, A, B, C. Well, the C was my other angle that I knew. I knew that it had to match M. So if I ended with a C on the left listing, I had to end with M on the right listing. And the symbol in between, that is the symbol for similarity. It's that single squiggle in the middle. Okay, let's take a look at another. Sometimes it doesn't look like triangles are similar, and we have to actually use some of the other rules that we reviewed yesterday. And those are the rules for angle congruence. So let's take a look at an example where we don't see the matching angles, but we actually can figure out that they match. So take a look at these two triangles. If I just look at the angles that are listed, that are given in the figure, I have a 28-degree angle, I have a 48-degree angle in the figure on the left. I have a 48-degree angle, and I have a 104-degree angle in the figure on the right. Well, I have one match. 48 degrees from the left matches 48 degrees from the right. But it does not look like I have a second match. But I can't rule it out yet. I'm actually going to need to calculate my third angle. I know that I can calculate this missing angle F. To do that, I'm actually going to take triangle sum theorem. 28 plus 48 will tell me how many degrees I've already used. It looks like I've already used 76 degrees. If I take 180, the total degree for the triangle, and I subtract the 76 I've already used, that leaves me with 104 degrees. So I know this angle is a 104 degree angle. Well, if that's a 104 degree angle, that means that I have a second match on angle measures. 104 degrees at angle F, 104 degrees at angle R. That means these triangles are in fact similar. So I know angle G is congruent to angle, G. Well, let's make that a Q. That'll make that much easier. Sorry about that. That's a Q. Angle Q. And I know angle F is congruent to the angle R. That is two angles congruent. Since I have two angles congruent, I can say the triangles are similar. Let's make our matchup. Triangle, let's list the one on the left, E, E, F, G, similar to the triangle. Well, E is not shaded. Which of my angles is not shaded in the figure on the right? Well, that would be a P. So P must be listed first. F is shaded pink. That matches R on the right. G is shaded yellow. That matches Q from the figure on the right. That is my triangle similarity statement, and my rule that I used was angle, angle, similarity. Good? All right, let's take a look at one more. I'm sorry, two more. So sometimes we know things are congruent in the angle world without having any angle degrees at all. Take a look at this example. If I take a look at this example, I can see clearly that I have one angle congruency that already exists. 67 degrees and 67 degrees. That is an angle degree match. Those angles would be congruent. But I don't have any other angle measures given to me. However, I do see another angle relationship. The other angle relationship that I see, we reviewed yesterday. It's called vertical angles. Remember, vertical angles are created when two lines intersect. And when two lines intersect, the vertical angles are opposite of each other at the intersection. So if I look at this picture, I actually have intersecting lines. I have the line LW intersecting the line JY. If you see that intersection, then it's easy to see that there are vertical angles within our triangle. So, where are my vertical angles? My vertical angles are actually right here. Does everybody see that? Now, the vertical angles in this picture have to be named very carefully. I can't name them angle in because there are too many options for what that could mean. I could mean angle in on the left side, angle in on the right side, angle in down here at the bottom. I could be angle in over here on the left on the bottom. There are too many angles at that point. So when I name the angle, I have to name the angles using 3 points. Start at J, turn around at N, and go to L. That tells me my angle JNL, N is where the corner is. The vertical angle for it, I'm going to start at W. I'm going to go to N and turn around and go to Y. So I would name it WNY. That names that angle at the corner N, where I start at W, go to N, and turn around to Y. That names my vertical angles. Okay, so I have vertical angles that are congruent. I also had the angle J that was congruent to the angle W. That means that I have similar triangles. So I'm going to name them. When I name these similar triangles, I'll say triangle JNL. That's my top triangle. Is similar to triangle. Well, what matches the J? Well, that was the W. I then went to the corner of the triangle with vertex N, which had a vertical match on the other side. L is my corner that is not marked at all, so that must match the Y. And that was by angle, angle, similarity. Okay, one more example. Okay, here again, I'm looking at this picture and I can clearly see one set of angles that are already congruent. I have angle D congruent to angle E. That one is already established for me. Angle D is congruent to angle E. Now the question is there any other kind of angle in this picture that I know is congruent even though it's not marked? The answer is yes, because I have parallel segments. Do you see that AD and EG are parallel? I know that because of this little triangle marking on each of the lines. Well, those lines are crossed by a transversal CH. Well, in our lesson yesterday, we reviewed some special types of angles that are created when you have parallel lines crossed by a transversal. And one of those relationships is in this picture. If I look inside my triangles, right here and right here, those are the same angles as what I would have here and here. So what kind of angles are those? Well, they're alternate exterior angles. Oh, that's right. And yesterday we learned alternate exterior angles are congruent. So we can say angle CBD is congruent to the angle EFH because we have parallel lines and those are alternate exterior angles. Okay, well, that's two angle congruencies. That means that I can say the triangles are congruent. So I'm going to name the first triangle, triangle EFH. That's the triangle at the bottom left. It is similar to triangle. Well, what angle matches angle E? Well, angle E was my yellow highlighted angle. So if angle E was my yellow highlighted angle, what does that match in the other triangle? That would be D. Everybody see that? Okay, what matches F? Well, F was my red marked angle. I'm going to use B as the matching corner. And then H was not marked. That will match C. And that is by angle similarity. I hope this helps you understand angle similarity. And I will be back with you later to talk about the other two shortcuts.